All right, let's dive into a concept that's right at the heart of what makes Python so powerful, polymorphism. I know it's a bit of a fancy word, but the idea behind it is actually pretty simple and, honestly, brilliant. It's all about one name doing many different jobs. So how does that even work in code? How can a single command, just one word, kick off completely different actions depending on the situation? Well, that's exactly the puzzle we're going to solve today. Think about it like this. Just consider the word open. You can open a door, right? That means physically pushing or pulling it. You can open a book, which means flipping the cover. Or you can open an app, which means firing up some software. See? It's the exact same word, but the action is totally different based on what you're opening. And that right there is polymorphism in a nutshell. The word literally means one name, many forms. In the world of programming, this means a single method name can trigger all sorts of different behaviors, all depending on the object you're using it with. The big takeaway here, context is everything. Okay, first up, let's look at this idea of one word, many actions. You're about to see how this one concept can take your code from kinda messy to super elegant. Now take a look at this comparison, because this is where it really clicks. Without polymorphism, you'd be stuck creating a different function name for every little thing. Open door, open book, open app. It just gets messy fast. But with polymorphism, you get this one clean, beautiful interface, just object.open. Your code instantly becomes way cleaner and a whole lot easier to work with. So how do we actually pull this off in our code? Well, the most common way is through inheritance, which, let's call it the family method. Everything kicks off with a parent class, kind of like a blueprint. So let's picture an animal class. We'll give it a basic method called sound function, which just represents a generic animal sound. And now let's bring in the kids, a dog class and a cat class. Now, because they're both types of animal, they automatically inherit that sounding method. But here's the key. They each get to provide their own special version of it. This is where the cool part happens. We can throw a dog object and a cat object into the very same list, and then just loop through it. And inside that loop, we don't have to check if it's a dog or a cat. Nope, we just tell each animal, hey, make your sound. We call a.sound on every single one. And what's the result? The exact same method call gives us completely different results. The dog barks, the cat meows. Python just figures it all out for us. That, my friends, is polymorphism in action. So how in the world does Python know which sound to make? Well, when your code is actually running, what we call runtime, Python takes a quick peek at the object's real type. It asks, is this a dog? If so, it calls the dog's version of sound. Oh, is this one a cat? Then it calls the cat's version. It all happens automatically, right on the fly. Okay, but what if the objects aren't related at all? What if there's no family connection? Well, that brings us to a very Python-y idea. Let's call it the duck imposter. You're going to hear this saying all the time in the Python world. If it looks like a duck, walks like a duck, and quacks like a duck, then it must be a duck. Just keep that idea in your head because it is the key to understanding this next part. So check this out. We have a car class and a person class. They have absolutely nothing to do with each other. No inheritance, no family tree. But, and this is the important part, they both have a method called move. That shared method name is the only thing that matters here. And this is the very heart of what we call duck typing. Python doesn't really care about an object's official class type. It just asks a simple question. Hey object, can you do the move thing? If the object has that method, Python's happy to run it. It's all about what an object can do, not what it is. Now, you might be thinking polymorphism is some kind of advanced, high-level feature you'll rarely use. But the truth is, you've probably been using it this whole time without even knowing it. Just think about the good old plus sign. You know, plus. When you use it with numbers like 2 plus 3, what happens? Python does math, and you get 5. Simple enough? But what happens if you use that exact same symbol with text? If you type A plus B, Python doesn't throw an error. No, it does something completely different. It performs concatenation. It just sticks the two strings together to give you AB. And there you have it, the same operator, a plus sign, causing totally different behavior based on the type of data you give it. This is polymorphism, hiding in plain sight. It's a powerful idea that's baked right into the core of Python itself. So,
We've covered the what and the how. But now let's get to the really important question, the why. Why should you even care about this? What's the real payoff of using polymorphism?
Well, it matters a lot. For one, it makes your code so much cleaner and more intuitive. It also gives you this amazing flexibility to add new things later without having to tear apart all your old code. Just think about a video game. You could have one single attack command, and that one command could make a warrior swing a sword, a soldier fire a gun, or a mage cast a spell. That's the power of polymorphism. Now, before we wrap up, let's clear up a common point of confusion. What we've been looking at is called method overriding. That's where a child class provides its own special version of a parent's method. This is different from method overloading, which is having multiple methods with the same name but different parameters. Python doesn't really do that in the traditional sense. The key thing to remember is that it's the object's type that decides which version of the method gets called. Okay, let's boil this all down. Here are the crucial points. Polymorphism is just one name, many behaviors. You can achieve it through inheritance, the family method, or through duck typing, which is all about behavior. Python makes the decision about which action to take while the code is running. And the whole point of all this, to write code that's flexible, powerful, and way easier to read. The funny thing is, once you grasp this pattern of one name, many forms, you'll start seeing it absolutely everywhere in Python. So the real question for you is, now that you know about this powerful concept, how are you going to use it to make your next project that much cleaner and more elegant?